Why did relays and vacuum tubes store digital memory? Imagine a time when computers didn't have tiny chips or flashing screens. Instead, they relied on big, bulky devices to hold digital information. That's where relays and vacuum tubes come into play. These early electronic parts were the first to store digital memory because they could representing and keep binary states, which are the foundation of all digital data. Binary states are simply the two options of 0 and 1, and digital electronics need a way to physically hold these states. Relays are electromechanical switches that can be either open or closed, making them perfect for representing 0 or 1. When a relay is closed, it can hold its position without needing continuous power, so it effectively stores one bit of data. But relays are slow, large, and wear out over time, so they weren't ideal for high-speed computers. Vacuum tubes are electronic devices that control electron flow through a vacuum inside a glass tube. They can switch on or off quickly, making them much faster than relays. A vacuum tube can representing a binary state by being in a conducting state or a non-conducting state. Early computers like the Electronic Numerical Integrator and Computer, or ENIAC, used hundreds of vacuum tubes to perform logic operations and store data. Vacuum tubes could switch states faster and more reliably than relays, which made them better suited for complex digital circuits. For memory storage, vacuum tubes had different methods. One way was to hold a bit by controlling whether the tube was conducting or not. Another method was using storage tubes like the Williams tube, which was a type of cathode ray tube. The Williams tube stored data as charged spots on a phosphor screen. The electron beam would write data by charging specific spots, and these charges would stay long enough to be read later. This was a big step forward because it allowed random access to stored bits, unlike earlier sequential storage methods. However, vacuum tubes had their downsides. They were large, generated a lot of heat, used a lot of power, and were prone to failure. These issues led to the development of magnetic core memory, which stored bits magnetically in tiny ferrite rings. Magnetic core memory was more reliable and non-volatile, meaning it kept data even when the power was off. In digital electronics, especially in flip-flops and counters, relays and vacuum tubes were the first building blocks for bistable circuits. Bistable circuits are circuits with two stable states, and they form the basis of memory elements like flip-flops. Early flip-flops used vacuum tubes or relays to hold one bit of data until it was changed by an input signal. Over time, these technologies were replaced by transistors and integrated circuits, which are smaller, faster, and more reliable. So, the reason relays and vacuum tubes stored digital memory is because they could physically representing and maintain binary states, which are essential for storing and processing digital information. Vacuum tubes allowed for faster and more complex memory systems like storage tubes, helping pave the way for modern digital memory. Their limitations in size, speed, and reliability eventually led to newer technologies, but they played a vital role in the evolution of digital electronics and memory systems.